Hi! Welcome to Project Ventive. Please like, share and subscribe, and also check out www.projectventive.com.
Tug, an autonomous robot. Robots seem so far away. We're so many years from Jetsons-esque machines that live among us and wash our dishes and fold our clothes. But the reality is the robots have arrived, you're just not noticing them. Take a robot called Tug, for instance. No, Tug can't talk philosophy with you, and Tug can't do your laundry. But Tug is a pioneer. Because in hospitals around the world, this robot is helping nurses and doctors care for patients by autonomously delivering food and drugs, shouldering the burden of time-consuming mundanity.
And now, it's rolling more and more into hotels, so get ready to see more of Tug.
Tug is an autonomous mobile robot made specifically for hospitals.
It delivers linens, medications and meals, and helps keep the hospital clean, while reducing our coworkers' physical workloads and their risk of injury.
It frees up our care teams to spend more time at the bedside with patients.
It has sensors that guide it through hospital spaces while steering clear of patients, visitors and caregivers.
If we're being honest, Tug isn't much to look at, unless you're particularly fond of boxes on wheels. But really, it's a self-driving car for the indoors. It navigates like a robocar would, using lasers to detect its surroundings and avoid obstacles. Step in front of it and it halts. Push an IV stand in its way and it roots around it. Like a self-driving car, Tug sees its world by spraying it with lasers. That tech is called lidar, the same algorithmically intense stuff at the heart of the dispute between the self-driving car programs of Uber and Google's Waymo. By bouncing lasers off its surroundings, Tug builds a highly detailed 3D map.
Supplementing that is a more traditional map of the hospital in Tug's head.
So it starts at a known point and uses geometry to position itself as it makes its way through the corridors. It can even call elevators to get to other floors. Sure, sometimes it gets stuck and needs human help if, say, a large cart is blocking its path. But for the early days of this kind of technology, Tug is surprisingly sophisticated, navigating a human world with relative ease. But that doesn't necessarily mean it puts humans at ease. Hospital administrators need all the help they can get, but can they trust a robot to work alongside doctors and nurses? The good news is Tug cannot go rogue. In a Pittsburgh office park, technicians at Aethon, which makes Tug, keep a watchful eye over robots all around the world, helping unstick them, for instance, if a human isn't around to help. That's because Aethon didn't have the luxury of waiting for culture to change to the point where people hurriedly adopt autonomous vehicles. So we built this back into the system where we can make customers comfortable that the Tugs were being watched, says Peter Seif of Aethon, even though they made the leap of faith with us that they could have autonomous vehicles running within their facility. This is the fascinating frontier of human-robot interaction. The robotic revolution is as much about getting the machines to adapt to us as it is about us adapting to the machines. So while Tug is designed to not run over toes, humans have to meet it halfway. That means treating these kinds of robots like your grandparents. Seriously. The idea is you help them when they get stuck or, heaven forbid, fall over.
And generally speaking, you just get the hell out of their way.
Design Dilemmas of Tug. Navigating a bustling hospital environment is difficult enough for a person pushing a delivery cart, and exceedingly more complex for a robot. Add in the ability to enter an elevator, go to the right floor, find the nursing station that ordered a particular medication, and deliver it on time. Years of development went into creating the decision-making capability within software, designing the complicated sensor array, and enhancing communication capabilities so that the Tug always knows where it is and where it's going. A touchscreen interface helps workers communicate with the robot and tell it what to do. The design team had to confront system compatibility issues with other wireless communication networks, as well as resistance from hospital workers wondering whether robots may be taking their jobs. Backstory of Tug. Robot entrepreneur Henry Thorne founded Aethon in 2001. A graduate of the Robotics Institute of Carnegie Mellon University, Thorne worked at General Motors for 5 years engineering robotic systems, including one of the largest robotic arc welding assembly lines ever created. In 1990, Thorne founded Cycle Time Corp., where he created the first graphical user interface for industrial robots, a technology now used on more than 5,000 robots within automotive manufacturing. In 1995, Thorne began working on mobile robots and created the first personal robot, CYE, originally sold by Probotics Inc. He founded Aethon in 2001 to commercialize bigger and brighter robots. The Tug was inspired by tugboats and their trailer hitch interface, according to Thorne. Tugs are actually base robots that can be attached to various delivery carts. Design impact of Tug. Tug robots are now employed in more than 100 hospitals delivering supplies, meals, and medications. The price tag is $105,000 for purchase or $1,500 per month for a lease.
Tugs could also be used to track and recover hospital equipment using RFID technology, perform security patrols, and transport medical waste.
In the future, they might be found delivering hotel room service or distributing merchandise within warehouses. How Tug travels. Before a Tug system is installed in a hospital, Aethon engineers map the landscape corresponding to the areas that the robot will travel and designate a home base, such as a pharmacy. Navigation software absorbs and accommodates the facility's layout. Computer. The onboard computer uses its detailed hospital map and navigation software to plan routes, avoid obstacles, and track its own location. Batteries. 4 lead-acid batteries provide 6 hours of operation, fully charging in 4 hours or less. Motors. 2 independent DC motors control wheel movements. It's not just Tug that's conquering the world. Autonomous machines are increasingly infiltrating our lives, be they companion robots or robots that help us do our jobs. Getting along with them means coming to terms with a new kind of relationship humans will form with what is essentially an invented species. Advantages of Tug Robot. 24/7 improved productivity. Tug works around the clock. It is a substitute for the labor needed to haul and transport goods, materials and clinical supplies in the hospital. Improved patient experience. Staff can spend more time with patients or assist nursing instead of transporting goods through the hospital. More time with the patient translates to better care and improved patient satisfaction scores. Worker safety and employee satisfaction. Injuries sustained while moving heavy loads are common. Employees often express relief when they no longer have to transport awkward carts. Patient safety. When clinical staff becomes distracted to look for missing materials or medications, they make mistakes and patient care suffers. If they are preoccupied with logistics tasks, they are not spending that time attending to the needs of the patient. Enhances the high-tech hospital. The Tug is a highly visible investment as it travels the halls, rides elevators and audibly speaks while performing its tasks.
Hospitals using Tugs are serious about improving efficiency.
It also enhances their reputation as being on the leading edge of medical. Thank you for watching.
Please like, share and subscribe to Project Ventive and also check out www.projectventive.com.